What up, Algebra Squad? Welcome to the 4.2 video for the first few examples. All right, so really quick, a little talk through of what it is that we did in 4.1. In 4.1, we looked at this sucker right here, and that is called the slope-intercept form of a linear function. And the reason why it has that name is because whatever coefficient this is right here, right in front of the x, that is going to be our slope, and the constant, or the number that sits by itself right here, that is called our y-intercept. That is why this is called slope-intercept form. So we learned how to write the equation of a line, this equation of a line, given different things, whether it was 2 points or whether it was a slope, whatever the case may be. Now, for 4.2, as you can see right here in the title, we're going to be writing equations in standard, okay, in standard form, which is this one right here, and in point slope form. Now, in standard form is, we've seen that before. That is where we put the term that has the x first, and then the y term, and then after the equal sign is where we put our constant, or the term that has no variable. The new one is going to be point slope form. The reason why this is titled point slope form is because when looking at the equation of a line in this format, we can very clearly see one of the points from that line. Remember, a line has infinite amount of points. We could see the x and the y from a point on that line, and we can also see the slope. That is why it's called point slope form. You can see a point and the slope. All right, now keep a note on the page numbers on the right side of your screen, and make sure you understand when to flip from book to a separate sheet of paper. Whenever we're doing the practice problems, make sure you flip to a separate sheet of paper so you don't run out of room. All right, now going into page 218. Example number 1. We're going to go ahead and create an equation in point slope form from or of a line that goes through this point right here, and it has a slope of -3/2. Okay, now the first thing I'm going to do is I'm going to remind you what point slope form is. Point slope form is y minus y1 equals slope times x minus x1. Now, x1 and y1, these right here in red, these are your x and your y from the points that are given to you. So I'm talking about these right here. And then the slope is also going to be what's given to us, or what we calculate. Sometimes it's not going to be given to us. All right, so let's see how easy this is. So you know that this is a y value. Sorry, that's not a y value. That's an x value, and that's a y value. So we can go ahead and put in those numbers. So as we said before, we have an x and a y of -2 and +7 for the y. And the slope given to us was a -3/2. All we have to do is plug them in. So the y value that we had was 7, plug it in, a slope of -3/2, and the x value of -2. Now, here you can see that it's going to ask us to simplify. So how is it that we can simplify this last step further? Well, remember that a minus negative is the same thing as adding. So if we go ahead and see what it is that they did to simplify, they just turned that minus negative into +2. That's it. Now, for this second part here is, how can we graph it? How can we graph an equation which is in point slope form? Well, the first thing is we already have a point in mind. We already know that the point -2, 7 is on that line. So if I were to look for -2, 7, I'd go to the left 2 and then up 1, 2, 3, 4, 5, 6, 7. There's a point right here. And the next thing that I'm going to do is I'm going to go ahead and use my slope, -3/2. And remember that slope is rise over run. When I say rise over run, means that the top number is the number that focuses on moving me up or down, or in my y's. My bottom number is my horizontal movement, left and right. So 2 things to take into account. Number 1, this is a negative slope. That means that my line needs to be going down from left to right. When you're looking at that line, it needs to be going down because it's a negative slope. So I'm going to go ahead and use 3 and 2 so I can get a negative line. I'm going to go ahead and move down 1, 2, 3, And then hopefully it makes sense that I'm not going to go to the left too, because if I go to the left too and create a point here, if you look at this line, that is a positive sloping line, and that is not what I want. So I'm going to go ahead and go 1 and 2, and I will land right here for my next point. All right. So if I continue this going down 1, 2, 3 to the right, 1, 2, I would land here. 1, 2, 3 to the right, 2, 1, 2, 3 to the right, 2, 1, 2, 3, 1, 2, 3 to the right, 2. Wait, whoops, that's not to the right, 2. To the right, 2. I should land right there. Did I make a mistake? I don't think so. Let me check. Yes, I did. Okay. Yeah, it looked a little bit weird. So in this one, I only jumped to the right once. So there's my second jump. And then 1, 2, 3 to the right, 1, 2. There should be right here. 1, 2, 3 to the right, 1, 2. Right there. Okay. So be careful with those jumps. Let me go ahead and delete this one and make them a bit smaller. Actually, I can just delete my little. There we go. All right, people. Hopefully you don't make those silly mistakes. Make sure it makes a nice straight line. And that's what it works. It helps to put as many points as possible. That way, when you're going over it with a ruler, they should all land on that same line. If they don't, then you miscounted. All right, so let's go ahead and do a check problem. Notice, once again, notice the problems and the page numbers that we're working on. I'm going to be jumping from example problems to practice problems. All right, determine the equation in point slope form. For the line that passes through. Okay, so the first thing I'm going to say, tell myself is, this is the form that I'm working with. Equals slope times x minus x1. From here, I'm going to go, okay, what is needed? What do I need to input into this so I can create the equation? I need to put out a y value, an x value, and the slope. Now, do I have an x and a y value that's given to me? I do. The x value that's given to me is a number 7, and the y value that's given to me is a number 5. So I can just put those numbers in. That's going to go right there. That's going to go right there. And then finally, what is the slope that's given to me? The slope of -3. So I can put that right there. All right. What would it look like? It'll look like this. Y equals -5. Why did I say y equals? Y minus 5 equals -3 times x minus 7. This right here is the equation of the line written in point slope form. Now, just so we could see it, just so everything can kind of make sense in our brain, let's go ahead and see what happens when we graph that. Let's first look at the point 7, comma 5 on decimals. Let's label that point, and the point is right there. And then let's go ahead and click enter so we can make a new line or a new thing. And then enter the equation that we created. All right, so we got y minus 5 equals -3 parentheses x minus 7. Okay, what do we got? Look at it. You see, we did create the equation of the line that goes through that point. So we did exactly what we needed to do. Cool. And let's just go ahead and fill in the blanks. You can see that the fill in the blanks is pretty much what we have here. So it's going to be y minus 5, our slope of -3, and then x minus 7. All right, now let's go ahead and graph this sucker. Let's make sure that Carreño doesn't miss some jumps here in the graphing. To graph this, we go ahead and use our point 7, 5, and then 7 is located right here. 7, and then up 5 units, so it's located right there. And then we have a slope of -3. My slope of -3, remember, it's -3/1. It's a line that takes me downwards. From left to right, it's a line that takes me downwards. So if I decide to go up 3 units, let me go up 3 units. And remember, every line that you're looking at is 2. So what I'm going to do is I'm going to be counting in between those lines so I can get up to 3. So it'll be 1, 2, 3. That's me going up 3. And now to the left 1. Here's my point. I'm going to go down 3. 1, 2, 3 to the right 1. There's my point right there. I'm going to go down 3 more. 1, 2, 3. And again to the right 1. Let's make sure this line is good. Ooh, nice. All right, there we have it. We are good to go. All right, example number 1, practice problems. We're going to go ahead and jump to page 225, and we're going to utilize the sheet of paper to do the work, but then the graphs on your book to graph our answer. All right, same question, same idea. We're going to be writing an equation in point slope form for the line that passes through the points that are given to us, and it has the slope that's also given to us. So here we go. Y minus y1 equals slope times x minus x1. The information that I need to input here would be my y, the slope, and x1. All right, so do I have an x and a y to work with? Yes, I do. I have -6 and -3. So how is this going to look like? Y minus the y that I have here is -3. So I would write it as -3 in parentheses. The slope that's given to me is -1. So I'll put -1. And then once again, my x value is -6. So minus -6, close parentheses. All right, we are pretty much done inputting the numbers. Let's just clean it up. We can clean this up by, instead of writing minus negative, we just write plus. Remember that getting rid of negatives is the same thing as adding, so we just write plus. Here we can also get rid of the 1. We could just get rid of the 1 and just put this negative there, but I don't want to freak anybody out. As long as the negative stays there, you can get rid of the 1. So here it is. Here is our function, our equation in point slope form. How do I graph it? Okay. It's a -6, -3. So what I'm going to do is I'm going to go, okay, I suggest you don't do this yet. I suggest you don't graph this yet and watch what I'm going to do right now. If I wanted to graph this at -6, -3, I would have to go 1, 2, 3, 4, 5. You see, I don't have enough space. And I could count by 2s, but, you know, it's my graph. I don't want to. So what I'll do is I'll probably push my graph. Whoa. I'll push my graph to the side more, say here, and say, okay, 1, 2, 3, 4, 5, 6 to the left 6, and then down 1, 2, and 3. So I have a point located at -6, 3, which is that point right there. And then my slope is -1, which, remember, slope is a fraction. And -1 or 1, 1, it's a staircase. It's a negative fraction. So your line needs to go downwards. And it's also a staircase that's created by 1, 1, 1, 1, 1, 1. It's a small staircase going by ones. So my staircase would look like this. See? Now, here's the thing. I could graph this and I can, that's it, just leave it like that. But what I'm going to do is, just to show you guys that you can do anything with your graph, is I'm going to move this graph a little bit more. I'm going to move this graph this way. You can see that what I'm going to do is I'm taking all my stuff that way. I'm taking my stuff that way. What I want is for my viewer or whoever's looking at my graph to get a better picture of my graph. Okay. So once again, this is it. This is my final graph. I'm going to go ahead and do it here and here. That's going to be my Y. There's going to be my X's. I have a point at 1, 2, 3, 4, 5, 6 to the left and 1, 2, 3 down. And then I have down 1 to the right 1, down 1 to the right 1, down 1. So you could see that you could see more of the line. You could see that you could see. You could see that you could see. So what I'm saying is you could see more of the line if I do it that way. Okay. And you're able to do that because the coordinate, the X and Y axis was not given to us. So we can create it however we want. And that's how I chose to create it. All right. Question number 2. I'm going to go ahead and encourage you guys to pause it right now and complete this on your own if you haven't done so. All right, here we go. Y minus Y1 equals slope times X minus X1. The values that I need to input are my Y, the slope, and X. I'm going to go ahead and write them right here. My x is -7, my y is 6, and the slope is 0. Oh, that's kind of weird, a slope of 0. Let's start to think about that for a second. What is a slope of 0? Remember that slope is how much a line tilts. As you can see, this line right here to the right, I'm sorry, left, it goes to the right one, down one, right one, down one, or you could say down one, right one. So that is the tilt that this line has. So what does it mean that a slope of 0 is the tiltedness of a line? Well, hopefully you guys remember, 0 tilt means the line is completely horizontal. From left to right, it's horizontal. So let's see what that looks like. Now that I know that that's a horizontal line, let's go ahead and put the numbers in here to see what that comes out to be. Y is 6 equals slope of 0, and then x minus -7. Okay, so two things that we can notice here. Number one, we could write this as +7, and number two, it doesn't matter however you write that, because anything times 0 is 0. It's all going to be eliminated by that 0. So I could simplify that by that simple idea and say, this is pretty much it. This is pretty much what we're working with. So that is our answer. Y minus 6 equals 0. So for some of you that understood when we were doing graphs, what would happen if I take this 6 to the other side by addition? It would look like this. Y equals 6. That is the equation of a line where, whoa, you go where your y is 1, 2, 3, 4, 5, 6. And then from there, you create your horizontal line. That is the line y equals 6. Okay, so it all kind of adds up. You could obviously tell that the point -7 and 6 will be on that line, because -7 would mean that you have to go 1, 2, 3, 4, 5, 6, 7 to the left, and then you'd have to go up 6 units. So your point will be located there on that line. So it all makes sense. Okay, number 3. We have an x value of -2, a y value of 11, and a slope of 4/3. Let's do it. All right, I'm going to erase this. I'm going to need some space here, so it's not getting in my head. Y minus y1 equals slope times x minus x1. The more you write this, the more it's going to stay in your brain. So don't think I'm doing it because, oh, I'm just trying to teach it to you or whatever. Like, the more I do this, the more it helps me also memorize it. If you think I've memorized it, even after 6 years of teaching it, I still have to like write it over and over and over to tell myself to not forget it. All right, let's do it. Y, what's my y value? 11. So y minus 11 equals my slope of 4/3 x, and then my x value given is -2. So let's go ahead and do it right now. Instead of writing minus -2, let's write it as +2. We're done. Now, what does it look like when we graph this? Remember, if you try to, I'm trying to do this quickly right now. I don't want to commit to graphing this fully. I just want to see where my numbers are going to land. That's an 11. That's a very big number when you're talking about that you have to go up 11 units. I don't have that much space. So what I need to do is take 11 into account and say, okay, that's an 11 in my y. So I have to go up by 11 units. So what I'll do is I'll go, okay, you know what? Let me just do this one counting by 2s, where, let me see if I have enough room. Did I give myself enough room here saying 2, 4, 6, 8, 10, 12, perfect. 2, 4, 6, 8, 10, 12. All right, so let's go ahead and graph that. That's going to be -2, 11. It's located right here. That's the point. Done. -2, 11. And now let's do the slope. Think about it. This is a positive slope. 4/3 is a positive slope. So my line should go up like that. From left to right, it should go up. So instead of going up 4, which I 1, 2, 3, I don't have enough space to go up 4. So I'll go down 4 and to the left 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 2, 3, 4. 1, 2, 3. Okay. Yeah, I got it. I'm gonna stick with that. Okay. There it is. Good to go. Were those all the problems there? Just want to make sure. Yeah. All right, example number 2. We're back to page 219. So go ahead and flip back to your book. Let's go ahead and do the fill in the blanks in your book. Now, let's see what this one is asking. Remember that anytime there's a new example, it's a new question. All right, it's a new idea. Write an equation in point slope form. Okay, we know how to do this. Point slope form for the line that passes through the given 2 points. Ooh, okay, so before they gave us a point and the slope. Now they're giving us 2 points. So what do? Well, if you look at, once again, what we have to create here, for us to create the equation in point slope form, which I'm writing right now, we need an x and a y and an x, which we already have. We already have an x and a y here and an x and a y here. We could use any of those. But the one thing that we don't have is the slope. What is the slope of a line that goes through those points? And the good thing is that it's okay, because with 2 points, we can calculate slope, right? With 2 points, we can calculate slope. With something that we've learned, it's called the slope formula, all right? We can calculate slope doing this. Now, they went ahead and labeled their x1, y1, x2, y2, and then they just plugged in those numbers, okay? Go ahead and follow the math. Look at those green numbers and look at the orange numbers, or whatever color that is. Right now, my screen is showing green and orange. And it's going to end up in 4/4, or the same thing as 1, okay? You could see that the book said that x1 and y1 are these numbers, these points, and x2, y2, they use these points. And remember, the labeling doesn't matter. You can label them however you want. So after we do that, after we know what the slope is, that's pretty much it. We just do the same thing that we did in example number 1. We grab the slope, and you know what else we grab? We grab any of these points. It doesn't matter which point you want to grab, because we need an x and a y. Remember, we need an x and a y to plug it in here. So we know that the 1 from the slope is going to go into the formula, and now we need an x and a y. It doesn't matter which ones you guys choose. The book decided to use this as their point, okay? That's what the book decided to do. So they put a -3 from the y, and they put the +6. And then when we clean this up, look what happens. The minus -3 turns into addition. And also they got rid of this 1 right here, because that's a 1 of multiplication. I actually suggest, even though it does say to, it suggests to simplify and take away the 1, I would actually argue to leave the 1 there, because it helps you see the slope. That 1, it's still the slope. So if you were to delete it, a lot of students would be like, where's the slope? All right. Pause it right now and try this one on your own. Select an equation in point slope form. All right, say less. The first thing, what I'm going to do right now is I'm going to create myself point slope form to see what I have, see what I need, and paint myself a picture here. All right, that's point slope form. I need to input these numbers right here. And it passes through these 2 points. Okay, so I do have x and y, which I can use right here and right here, but I need a slope. So what I'll do is I'll go ahead and use my x and y points so I can find slope. So let's go ahead and find slope. I'll go ahead and call this x1, y1, and we'll call this x2, y2. So based on how I have it written, that's -2 minus 18 and -11 minus -16. Okay. So what do we got here? All right, so we got a -2 minus 18. What is -2 minus 18? They're both from the same team. That's a -2 and a -18. That's going to give us negative 20. Okay, we got negative 20. Next, what do we get? A negative 11 plus 16. Remember, minus negative is the same thing as plus. Here, they actually fight off. They're not the same symbol, so they are going to cancel each other out. Who has more? The 16 has more. It has 5 more. So this is what we're going to be left with. And then we have, what is negative 20 divided by 5? Negative 20 divided by 5 is negative 4. Cool stuff. All right, we know that our slope is negative 4. We can go ahead and look at our options and say, that is not the slope that I'm looking for, and that is not the slope that I'm looking for. So I know for a fact that D and B are wrong. Now, we could say that it's none of these. I don't know that yet, so I'm not going to weed any of those out. So what I'll do next is say, okay, well, let me use my answer choices to see what the book did. If you look at what the book inputted for all of them, 2, 2, 2, 11, 11, 11, right? They used these points. So which of the choices are using those points correctly? Which choice is are the points being used correctly? So if I were to put as my y this negative 2, it would look like this. So let's go ahead and do it. I'm going to go ahead and input the slope of negative 4 times x minus, what's the x value? 11. All right, so what happens here? Minus negative is the addition, minus negative is addition. I wanted to say y plus 2 and x plus 11. What is the correct answer here? The correct answer is A. All right, this is the only one that has all that correct information. All right. All right, let's go ahead and talk about example number 3. Oh, wait. Yeah, this is what we need to talk about. This was what I assigned for homework. So pause it right now and try to do this on your own. All right, guys. So for this one, I am going to do only a few of them with you guys, only a few of them that actually none of them. I'm going to go ahead and give you guys the answers. And please go ahead and work towards those answers. Remember that there are 2 answers. There's 2 ways of writing it because we have 2 different points. We have that point and this point. So this equation that's right here is created with these points, and that equation is created with these points. So it's up to you actually to decide what points you want to use to create your equation. So create whichever one you want. I'll go ahead and show you the answers right here. If you have any questions in any of this, please let me know, and I will help you understand them. But here are your answers. If you don't want to look at them, try to do it without looking at them. Or if you don't get it, try to work towards those answers. All right, now really quick. Just a very fast recap of example 1 and 2, what we just did. So for example 1 and 2, we talked about this new thing right here, which is called the point slope formula or equation, the point slope equation. This is just the way that a line is, the equation of a line is written. So we could see a point, an x and a y, and the slope. That's why it's called point slope. So in example number 1, they said, hey, can you write the equation in point slope form if we give you a point and the slope? And it's kind of like, yeah, well, obvious, duh. Yes, we can, because if you give us the point, we'll go ahead and plug in the points, the x and the y, where they go. And if you give us slope, we'll go ahead and plug that in as well. That's pretty much it. Okay, cool. What was example number 2? Example number 2 said, what happens when we give you 2 points? Can you create the equation if we give you 2 points? And the answer was, well, first I need to find slope. And to find slope, we need to do the slope formula. Using these 2 points right here, x1, y1, x2, y2, we can find slope. As soon as we find slope, then we can go ahead and continue as we did for the first example. As soon as we get slope right here, we're able to just put it back into the equation. And then we can choose any of the points that were given to us. We can either choose the x1, y1 point or the x2, y2 point. We'll grab their coordinates, x and y, and plug them into the equation to be finished. And that's it. All right. So next example, example number 3. Here's a visual of example number 3. Example number 3 wants us to grab something that is in point slope form. This is point slope form. And they want us to take it into slope intercept form. All right. At the beginning of this video, I told you guys what slope intercept form was. And that's what we did in 4.1. So let's go ahead and see how the book walks us through it. All right. We're jumping back to page 219, right back in your book. Here we have an equation which is in point slope form. Can you go ahead and write it in slope intercept form? And as a little reminder, slope intercept form looks like this: y equals mx plus b. All right. Now, what are the steps? Well, the steps is to do the math that we kind of are able to do. And the math here is there's nothing that you can do here. You can't add that. You can't subtract this. The only thing that we can kind of do right now is distribute. You can distribute that -2. And when you distribute that -2, it looks like that. So that's a distributive property. Next, the next thing you want to do is notice what this looks like and notice what we want to make it look like, where y is by itself. So if we want y by itself, we need to take 4 to the other side by doing the opposite. That's an addition of 4. So by subtracting it by 4, we are able to now get it in slope intercept form. Done. Cool. Now, a lot of students, while I do this, they're kind of going, what are we even learning? We're just manipulating equations of lines so they look differently. And why do we care? Why do we have to move equations around so they look different? Because by moving them around, moving the numbers around, we are able to tell or pick out different parts of the graph. So in the point slope form, we could see a point and the slope of the line. In another form, the slope intercept form, we can see the slope and the intercept of the line. So keep an eye of what I did right here in Desmos, which was the original. Now let's go ahead and create the slope intercept form, which is y equals -2x. What does that say? Plus 8. And once again, here it is. Check it out. It's green and purple. It's the same line. It should not be a different line. If it's a different lines and you're checking on Desmos, that means you did some work wrong. So as long as you're doing property of equality, meaning you're doing the same thing to both sides. We did -4 here and -4 here. Property of equality, you're keeping everything equivalent, the same. So the line should not change. All right. So go ahead and try it out with this one right here, this check problem. All right. In this check problem, check out what I'm going to do. I'm going to do Carreño's way. And I'm going to tell you what the book would like you guys to do, or just to have in your back pocket in case you ever need it. How would I tell you to solve this question right here? Go ahead and it's asking to write this in slope intercept form. Y equals mx plus b. We're still working. Actually, we're working on a piece of paper right now. On the piece of paper, you will not have enough room right now to do this one. So what I'm going to do is pretty much take the same route that we did in the previous example. Oh, my Lanta. The previous example, the math that was done there is pretty much what I always do, regardless of the numbers. The book, if there are any fractions, the book likes to take a slightly alternate route. And I'm going to show you both so you can choose whatever you want. Now, Carreño's route, here we go. How can I turn this into slope intercept form? Well, the first and only thing that we can pretty much do with math right here is the distributive property. So we have y plus 3 equals -1/2 times x is -1/2 x. -1/2 times 8, that's going to give me a +4. Remember that positive times negative, negative times negative is positive. And then anytime you multiply a number by a negative, you're just cutting that number in half. So half of 8 is 4. Okay. Our last step here is, remember that we want to put it in slope intercept form. That is when your y value is by itself. So for me to have a y value by itself right now, I need to take 3 to the other side. So I'm going to do the opposite, minus 3. That is going to give me -1/2 x plus 1. And I'm done. Carreño's method is done. I mean, I didn't make it up, but that's the way the route that I take. All right, now it didn't seem too bad. And it's because the numbers are pretty much very simple. If it gets a little bit more interesting with fractions, my method might seem a little scary to some people. Now, here is the method that the book suggests. If you don't like using fractions, you can get rid of the fraction right away. How do we get rid of a fraction? By cutting off the bottom number. The bottom number is what creates the fraction. This is only the number 2. If I put a denominator, this is creating a division. All right, it's kind of weird, but think about it that way. So for us to get rid of that 2, we're going to do the opposite of that 2. We always get rid of a number by doing the opposite, the inverse operation. That 2 is causing division. So I'm going to grab everything and multiply by 2. Whatever you do to one side must be done to the other side, because that's called properties of equality. Keep it the same. All right, so what happens here? Well, what happens here is exactly what I want to happen, which is my 2 cancels out. But something else happens, which, you know, it creates a wave. 2 times y is 2y, and 2 times 3 is 6. Everything else here pretty much stays the same. So that -1 is still alive, staying alive. And then the x minus 8 staying alive as well. All right. If you can agree with me, we can also do a little distributive property right here to get rid of parentheses and that little -1 that's just chilling. So nothing happens here. We have a -1x plus 8. If you're asking me, can I get rid of that 1 right here and not write it? I would say keep it, because it's going to be our slope in a second. All right. So once again, we need to get our y by itself. That's the main idea. So as I'm working right now, and you're probably going, why is it going so fast? I'm getting y by itself. The way to do that will be taking that 6 to the other side by subtracting, giving me a +2. Then finally, you can see that this is my last step. I know that these 2 are multiplying. Inverse operation would be to divide. Whatever you do to one side, do it to everything else on the other side. Anything divided by itself is 1, leaving me just 1y or just y. And then here we have, you remember when I told you not to get rid of that 1? Just leave it there, because now that's your slope. And remember, a slope in a fraction is very easy to tell, or to use, or interpret. Rise over run. Once again, anything divided by itself is 1. So here we go. Look at that. All right, so you get to look at these 2 and say, which one do I prefer? Whatever you want, whatever floats your boat. Remember that the math and the numbers were very, very simple. So you can actually use my method for that one. All right, so let's go ahead and do these practice problems. Pause it and try it. Pause it and try it. All right, well, what I'm going to do right now is I'm going to show you the answer for number 8, and I'm going to go ahead and do it pretty quickly. All right, what we want to do right here is the distributive property, where we do 4/5 times x is 4/5, and 4/5 times 5. Fraction times the whole number, just turn it into a fraction times a fraction. When you do a fraction times a fraction, your numerators multiply, your top numbers, and your bottom numbers multiply. Another way that you can think about this quickly would be, once again, you have a fraction times a whole number. The pretty much only thing that happens is your whole number and your denominator multiply, and then your numerator and your denominator stays the same. Okay, 20 divided by 5 is 4. All of that just to get an answer of 4. So 4/5 times 5 is the same thing as 4. What else do I do here? I'll take 1 to the other side, cancel, cancel, and now I have my slope of 4/5 and my y-intercept of 5. I am able to graph this very easily by putting the y-intercept as 5 and then doing rise over run with 4/5. All right, pause it right now. I'm going to give you the answer for number 9 and then do the work pretty quickly. Here's the answer. All right, once again, no secret, distributive property. Y plus 5 is equal to -6x, and then negative times positive is negative. 6 times 7 is 42. Boom. The next thing we want to do here is get our constants, or numbers that don't have a variable, on the same side by inverse operation. That's going to leave me with negative 6x. Negative 42 minus 5. If you're in the negative numbers and you are still subtracting, that means you are still going towards the negative side. So you're just going to get more negative. Oh, don't be negative. Be positive. All right, here we go. Number 10. The answer is coming in 3, 2, 1. Pause it if you don't want to see it. Here it is. All right, distributed property. Let's see what we got here. Y plus 6 equals negative 3 over 4x. And let's see what this looks like. It's a negative 3/4 times a positive 8. A negative times a positive is a negative. So I'm just going to put that there. Now I'll go ahead and say, okay, what's 3 over 4 times 8? Remember the shortcut? What's 3 times 8? 3 times 8 is 24. Keep the same denominator as 4. 24 divided by 4 is what? Or 4 times what is 24? That's the number 6. So that's going to be 6. The more you do this, the more you practice, the more that math is going to be done in your head. Hopefully you don't rush it and make silly mistakes that I do at times. Negative 6 minus 6 is going to give you negative 12. Be careful. Negative 12. Don't say that that's 0. All right. Number 11. If you don't want to see the answer, pause it and try it on your own. If not, the answer is coming in 3, 2. I lied to you. I showed you the answer at 2. All right. Distribute. We got y plus 2 equals 1, 6 x. And then we have negative, because it's 1, 6, which is positive times a negative 4. Positive times a negative is a negative. And then remember that the 1 just the 1 multiplies with the 4. We can reduce this fraction if we wanted. 4 over 6, we can divide both of those numbers by 2 to get 2/3. You don't have to, but I'm just doing it right now just so later on I don't have to do more work if that's going to get in the way. Take 2 to the other side so I can get my constants or numbers that don't have a variable together. That's going to leave me at 1, 6x. Woo! Okay, so now what is this? Here's a little cheat code or just a breakdown of how to do fractions. We have the fraction negative 2/3 minus 2. How do we deal with that? You can only understand what we're about to do if you just put numbers that you understand. What's negative 5 minus 2? Hopefully, your brain is telling you negative 7. Okay, so the first thing, let's understand it. Since we're in the same family of symbol right here, we're going to stay in the negatives. So that's the first thing I'm going to do. Do not worry about the negatives and positives anymore. Do not. Because we already know that if we have a negative number minus another number, don't say minus a negative number. We're just saying minus another negative number. We're going to get negative still. And then a 5 and a 2 makes a 7. How did a 5 and a 2 make a 7? By adding. Whoop. All right. So 2/3, we're going to add it with 2 to equal our answer. In reality, we're not going to use 2. We want to use a fraction. 2 is equal to what fraction? 2 is equal to 2 over 1, or is equal to 4 over 2, or is equal to 6 over 3, right? So what fraction can I put here to make my addition easy? Remember that adding or subtracting fractions, you want them to have the same denominator. So what fraction is the number 2 that has a 3 in the denominator? What divided by 3 equals 2? And that's the number 6. All right, here's what makes it easy. Since we have the same denominator, we keep, and now we have 2 plus 6 is 8. So 8/3. There we go. And I did that one for free. All right, so we are skipping this for now. We will do it live. Now let's go ahead and do the example number 5. Actually, no, we're not. We're going to keep it here. Our next video will have example number 5. Peace out.